morning, my dear students, and welcome to the world of electronics. Our lesson for today is taken from lesson 1 of module 2 under ALX 215, which is audio video system. The lesson tackles about the principles and theories of digital TV. Basically, there are 5 types of digital TV. This is in accordance with the supported video format. These are the SDTV, or the so-called standard definition TV. We have the ADTV, or enhanced definition TV, HDTV, or high definition TV, FHD-TV, or full high definition TV, and the last one is UHD-TV, or ultra high definition TV. We have one available defective digital TV here, wherein the brand is Devant and the model number is 40DL540, wherein the screen resolution is 1920 horizontal resolutions and 1080 vertical resolutions, and the supported video format is FHD, or full high definition, wherein the screen aspect ratio is 16:9, or 16 wide and 9 high. Actually, the size of the screen here, based from the model number stated, that was 40DL540. The 40 there indicates the size of the screen, and that is 40 inches. So let us measure. So the size of the screen is not actually measured horizontally nor vertically. The size of the screen is actually measured diagonally. It could be like this, or it could be like this. This is 40 inches. So therefore, this TV is LED TV FHD and 40 inches. It is called LED, by the way, class, because the backlight of this digital TV is made of light emitting diodes. We have here the light emitting diodes. Okay. These are the light emitting diodes that produces bright light in order to activate the liquid crystal between these two electrodes, the vertically polarized electrode and the horizontally polarized electrode. Between these two electrodes is the liquid crystal, which will display the picture caused by the current distributed by this LED. No? The brightness of the LED activates the liquid crystal display actually in order to display the picture. No? Okay. So in other words, this is LCD LED. No? Because what is commonly known is LED only, LED TV. Because there is a presence of liquid crystal between these two electrodes, no? Between these two electrodes, vertical and horizontal polarizing electrodes, the liquid crystal. So in other words, this is LCD LED. LCD LED. Whereas the obsolete LCD before, that was LCD CFL, cathode fluorescent lamp, because it uses fluorescent lamp. We have here a very thin fluorescent lamp. Usually, the obsolete LCD uses 10 to 20 fluorescent lamp connected in parallel, and they are also placed in front. No, it is just at the back of the LCD screen. So we call this one as LCD CFL, LCD cathode fluorescent lamp as the backlight, LCD LED as the backlight. LCD CFL has been replaced by LCD LED because of the disadvantages. Fluorescent lamp lifespan is short compared to the light emitting diode, which is long lifespan. And the quality of the picture also. Lower contrast for the CFL, higher contrast for the LED. When we say higher contrast ratio, very bright and or very white, very bright and very dark for the LED. Whereas for the CFL, very low because not so dark, not so white, and also the lifespan. Okay. Okay, let us now come to the structure of the LCD screen and their functions. Okay, we have here. Actually, included in the LCD screen structure are the strips of leads. There are actually 4 strips here. Strip of leads that has 10 leads in series. They are actually connected in series. It goes like this. Okay. This is now the symbol of lead. Okay. It is supplied with voltage DC. So, these 4 strips are actually connected in series. So, let us try to measure how much is the voltage being supplied. Okay. Use DC voltmeter. We set the select button to DC voltmeter. Then, let us measure how much is the voltage across. Because this is now the connector, the red is the positive side and the black is the negative side. Being supplied by this power supply circuit here of the LED. So, we have here. It reached here 128.2 volts. No? 128.2 volts. That is now the DC voltage supplied to the series of leads there. There are 40 leads which are connected in series. Supplied by this lead driver. We call this one as lead drive because it is a regulated voltage. The current and the voltage are efficiently regulated without any variation. That is to prevent the flickering of brightness. There should be no flickering of light. Darker, brighter, brighter for every now and then. That is eliminated because of the lead driver here, which is made of regulator. It regulates the voltage and the current. It is made constant and permanent. That is to prevent the problem of flickering of light. Okay? So, therefore, the applied voltage there is 128 volts. 128 volts divided by, you have here, 128 volts divided by 40 because there are 40 leads which are connected in series. So that is 3, 120, then this is 8, 80. So 3.2 volts. In other words, every LED is supplied with 3.2 volts. For that is now the typical supply voltage for the LED, diba? It ranges from 1.5 to 3.7 and typically it is 3.2 for the LED of this digital TV backlights. So, unlike this backlight here, this backlight actually, which is also made of LED, is applied to a 32 inches digital TV. Usually it is a Devant, no Devant. So, there are 2 strips with 10 leads in series each. The 2 strips are actually connected in parallel. We have here. See? The red and the red are connected together. The white and the white are connected together. In other words, the 2 strips are connected in parallel. So therefore, when it is connected in parallel, the applied voltage is 30 volts. 10 divided by 30 is 3 volts. Because it goes like this again. It goes like this. Another 10 leads here. Okay. It is connected like this. Parallel. 10 leads connected across each other. So 3 volts, 3 volts, 3 volts, 3 volts. So the same 3 volts, 3 volts, 3 volts. So this is 30 volts, 30 volts. So 30 volts is the applied voltage when the two strips are connected across each other or in parallel. Okay. Unlike this one, the applied voltage of this fluorescent lamp is around 800 to 1500 volts. Meaning to say that the motherboard is equipped with DC AC inverter, wherein the DC voltage, the small amount of DC voltage, let us say 8 volts, is inverted into AC. And the voltage there is increased to 800 to 1500 volts because this fluorescent lamp can be lighted by means of that amount of voltage. No? That is the main disadvantage also of using fluorescent lamp. That's why fluorescent lamp has been phased out or eliminated because of that performance. Low contrast, the lifespan is short, and higher amount of voltage also is applied, which is risky for the technician. No? Okay. Let us now come to the structure of LCD LED screen. No? We have here the screen. Composes of sheets and films. At first, let us discuss the strips of light emitting diodes are actually fastened on top of this metal frame. Then followed by this coil. Okay. Let us connect. Okay, it goes like this. The light emitting diodes produce light, very bright light, but the brightness is not uniform without the reflector. Once the lights are sent to the screen, LCD screen, there are dark and bright spots. So there is darker sides here, there is brighter here, because there is no uniformity of the distribution of light. So, and the light also is not so intense or high. So, because there are wasted light, the light that hits the frame will be wasted. It cannot be sent to the front. So, to increase the light, it is used with reflector. The reflector sheet is placed on top of this series or strips of light emitting diodes. It goes like this. Meaning to say that the light emitted by this light emitting diode will be directed towards the screen. So, this light that hits the corners will be bounced back towards the screen. Unlike without the reflector, so the light that hits the frame will be wasted. It cannot be bounced back to the front of the screen. So, that is the purpose of this reflector film or reflector sheet. The reflector sheet is actually made of a reflective material. That material is crystalline metal oxide. No? It is made of metal oxide, crystalline metal oxide. It is a very reflective material because all lights emitted by the light emitting diodes are reflected towards the front of the screen or the LCD screen. No? Okay. That is the main purpose. It is sometimes called this reflective material or reflector is sometimes called as dual brightness enhancement film because it increases the brightness. That's why it is dual enhancement or dual brightness enhancement. The brightness is increased or is doubled due to the reflections. No? Dual brightness enhancement film. It is a reflective material that it is made sure that all brightness or all lights are sent to the front of the LCD screen. No? Then it is followed by diffuser sheet. This is now a diffuser sheet. Okay? Diffuser sheet is placed after the reflector. This diffuser sheet is thicker and it is made of polymethyl methacrylate. It is polymethyl methacrylate. It is made of that material, wherein its main purpose is to distribute the light reflected by the reflector towards the screen via diffuser. It is distributed evenly or uniformly. There are no dark spot at this side. The light being emitted by the LED and reflected by the reflector is scattered evenly. No? Like for example this one. For the LED bulb. This is now the LED bulb. We are no longer using the incandescent bulb, which is made of vacuum glass and tungsten wire. This one is the diffuser. It is actually made of acrylic. The main purpose is to distribute or scatter the light emitted by the LED evenly or uniformly to all sides of this cover. So it is made of acrylic material, which will evenly or uniformly scatter or distribute the light without any dark spot. So, that is now the diffuser sheet or the diffuser film, which is made of polymethyl methacrylate material that distributes the light emitted by the LED uniformly. No? Then it is followed by we call this one as prism sheet. Prism sheet. Okay. The prism sheet actually is made of polyester film. It is also plastic. It is also an insulator. The prism sheet gathers the scattered light. Usually, from this diffuser sheet, although the light emitted by the light emitting diodes is scattered or distributed evenly or uniformly to avoid any dark spot, all is bright, no? So, there's a tendency that the light could be scattered. We have heard the LED, the reflector, then followed by the diffuser. Okay, reflector. The light is sent from the LED. The light is sent from the LED being reflected by the reflector to the diffuser. The diffuser now will scatter or will distribute the light from this edge to this edge we have here evenly. So, what comes next is the prism sheet. The prism sheet. So, the light that goes like this, it is no longer parallel, but it tends to stray from the direction, no? Is again realigned. It is realigned. Realign. by this optical or by this prism sheet. It is made straight again because from here it goes like this, it goes like that. The light is bent. There is a tendency to stray or to divert from its direction. So once it passes the prism sheet is actually made of polyester film that once again realign or align again the light vertically towards the screen. That is the main purpose of the prism sheet, which the purpose is to gather again vertically the bent lights being accumulated and gathered or distributed by the diffuser sheet. Okay. Then, what's come next is the we call this one as optical sheet. This is optical sheet actually. No? From the prism sheet the light is a little bit dimmer or darker. But once again, with the application of this optical sheet, the light is increased and the degree of uniformity of brightness is maintained on all sides. No? Once again, no dark spot. Wala mga dark spot after it is processed by the optical sheet. The optical sheet actually is made of acrylic or polycarbonate material. No, polycarbonate material. So, it is made sure that from the light emitting diodes that emits light to be sent to the liquid crystal display after this is very bright and intense. There is an intense light. It is made sure that all lights sent and emitted by the leads will be sent to the LCD screen without any waste. Okay. Okay, let us now come to the LCD screen. The panel of LCD screen composing of, because after this optical sheet, what follows is the LCD screen panel composing of the vertically polarized electrode and the horizontally polarized electrode. This is on the front. Okay. Then between these two electrodes are the liquid crystal. The liquid crystal is over here. Then the color filter. No? The vertically polarized electrode. Then we have the liquid crystal. Then we have the color filter before the horizontally polarized electrode. Okay. The reflector, the diffuser sheet, the prism sheet, and the optical sheet are used to intensify and gather the light from the LED efficiently in such a way that there is a very bright light displayed on the screen. The purpose of the light emitted by the light emitting diode is to excite, to activate the liquid crystal display here. Liquid crystal display. Okay? Liquid is actually made of indium tin oxide. Indium tin oxide with liquid with crystal. The liquid is actually made of indium tin oxide. No? Okay? Okay, once it is placed here, it goes like this. No? Okay. You can see that there is ink bleeds. It bleeds because actually this screen is broken already. So you can notice that it is somewhat a liquid. Diba? Ink black. Sometimes it is ink black or ink. No, it is the same as the ink of your ball pen. So it is bleeding because it is already broken. So that liquid is actually made of indium tin oxide. No? Okay. So at first, the light emitted by the LED is passing through the vertically polarized electrode we have here. Okay, it goes like that. Let us try to invert. Okay, it goes like this. Why? Okay, let us try it. Focus. Okay, actually there are two electrodes. We have here the vertically polarized electrode over here. This one. Vertically polarized electrode. Between them is the crystal display, the pixel, and the horizontally polarized electrode. Okay. If we will try to focus, we have here. If we will try to focus that there are dots of colors, we call them as pixel. Pixel. One pixel is composed of three colors: red, green, blue, red, green, blue, red, green, blue. No, aligned horizontally and vertically. So there are 1,920 pixels aligned horizontally, and there are 1,080 pixels arranged vertically. So in other words, if we are going to multiply them, there are actually 2.07 megapixel or 2.270,000 pixels in this screen. No? Because this is full high definition TV. Full high definition TV wherein the resolution is higher. Unlike the HD, the high definition TV, which is only 1280 pixels arranged horizontally and 720 arranged vertically, wherein the number of pixels on that screen of the HD is only less than 1 million. No? Less than 1 million. But if it is ultra high definition, which is the latest TV today or nowadays, that the number of pixels in the entire screen here is 8,300,000 pixels arranged horizontally and vertically. There are 3,840 pixels or resolutions arranged horizontally and 2,160 pixels arranged vertically. If we are going to multiply them, that results to 8,300,000 pixels. In case it is an ultra high definition TV. But since this is full high definition TV, wherein the resolutions is only 1,920 horizontal resolutions and 1,080 vertical resolutions, the number of pixels on this screen is 2,700,000 pixels only. No? So, vertically polarized electrode. What comes next is the liquid crystal. Then the pixel. We have here the pixel, wherein the colors are printed. Then the liquid crystal, then the pixel, then the horizontal polarized electrode. So once the light from the light emitting diode passes through the vertically polarized electrode, will be bent. The light is bent 90 degrees. So it goes like this again. This is now the vertically polarized, and this is now the horizontally polarized. Between them is the, let us have the pixel. Okay. Pixel. Blue, the green, and the red. Where is the red color chalk here? Okay, we have here the pixels placed after the vertically polarized electrode. The pixels are composed of three primary colors: blue, green, red. We have here the blue, green, red again. Okay, it goes like this: blue, green, red. Okay. These are now the pixels printed on the surface of that glass after the electrodes. The red, green, blue, red, green, blue, red, green, blue primary colors by electrical means, but by chemical means it is red, blue, yellow. But we are talking about the electrical signal. Usually the primary colors are blue, green, red, no? Okay. These are now the pixels. So in every pixel there are subpixels. There are subpixels. So halimbawa, red, green, blue, red, green, blue. Okay? This is one pixel. It is guarded with black matrix. One pixel is composed of three subpixels: red subpixel, green subpixel, and blue subpixel. Every subpixel is connected with the so-called field effect transistor. It is a micro thin film transistor, TFT, thin film transistor. Thin film transistor, wherein the red, the green, and the blue is connected with thin film transistor. The thin film transistor is composed of three electrodes: green, or the gate, the drain, and the source, or the base, the collector, and the emitter. So the drain is actually connected to the subcolor, subpixel. No? In other words, there are three thin film transistors for this one pixel that execute the red, the green, and the blue. So thin film, they are actually mounted on the surface of these pixels. What is the purpose of this thin film transistor, which are connected to every subcolor or subpixel, red, green, blue? The purpose is to switch on and off. Switch on and off rapidly. For example, so it goes like this. We have here the screen. Then we have here the subpixels. The pixel. Pixel. By the way, pixel is the short version of picture element. That brown color is actually, it is actually black because it is black matrix, because the red, the green, and the blue, red, then green, then the blue. In every pixel, there are actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 8 pixels. Remember, this is FHD, full high definition, which is composed of 2,070,000 pixels to the entire area of this screen. So, this is only example. There are only 12 in this example. For example, the picture color here is blue. The color of the shirt of that person is blue over here. Blue. Meaning to say, then over here is white. White. So, the pixels here, the three subcolors are lighted because the combination of red, green, and blue is white. But over here, only blue phosphor screen. This is phosphor, because there is phosphor in every pixel. Blue phosphor, green phosphor, red phosphor. That one is white phosphor for our fluorescent lamp at home. It is white phosphor. If you can see a fluorescent lamp which is made of blue color because there is a fluorescent lamp made of blue color. So the phosphor there is made of blue phosphor. But this one, red, green, blue phosphors. In this portion, that is the color of the t-shirt of a certain person being viewed on the screen. So only blue color, only blue phosphor is being activated. Whereas the green and the red are switch off, turned off. That is actually the responsibility of the thin film transistor that serves as a switch. It switches off automatically or rapidly the red and the green and turns on the blue. For example, this is yellow, for example. Over here is yellow. So, only green and red is activated or lighted because the combination of red and green is yellow. Or if it is violet, so a little amount of blue and red is lighted to make it violet. No, it goes like that. So the purpose of the thin film transistor is actually to switch on and off the phosphor of the pixel. No? Okay. So going back again to the electrodes. From the vertical to horizontal, the light from the lighting diode is twisted 90 degrees. 90 degrees. It is twisted by means of the liquid crystal, which is placed between the two electrodes, the vertically polarized electrode and the horizontally polarized electrode. Between these two electrodes are the liquid crystal, the pixel, the red, green, blue pixels, then the color filter before the horizontally polarized electrode. The purpose of the color filter is to control the intensity of light, no? To provide a high quality color on the screen once the picture is displayed.